neural network watermarking. I think you can see my screen now. Okay, of course, I start this presentation with a contextual slide, and it's quite difficult to speak today about neural networks and artificial intelligence. They are definitively at the heart of the today and the tomorrow solutions. They will be here for a while. And there is practically no field in which they are not applied. Leonardo just gave us this synthesis of MPAI activities, and this is a reality. I would just like to draw your attention about two aspects of particular interest for our project. First of all, is the dynamicity of the neural network. They are continuously renewed, and they are continuously renewed by academia, by research laboratories, but also by industries that with new data sets, with new computing capabilities, and with new needs, fine-tune or distillate the knowledge of neural networks for building new business verticals. Another thing I would like to draw attention is the fact that AI, the final goal is to serve autonomous process, robots, vehicles, medical decision-making, and so on. So while some tasks are for leisure, other of them are really critical, and the attention should be paid on how this neural network works and whether they work as forecasted. Why watermarking is useful for neural networks? Two main ideas. On the one hand, because machine learning is a costly field, they are statistics from late December 2022 that buying AI solution ranges between $6,000 to $300,000 US, while renting a pre-built module costs around $40K US a year. And statistics also shows that this will gradually increase, at least in the coming 10 years. During its life cycle, an AI solution can use multiple alternative neural networks to provide an inference, and identifying the ones that actually produce the inference, it's important. AI solution and NN can also be shared among multiple users during an application life chain, and keeping a track of this process, it's key for ensuring fair and trust in the usage of the network. And mainly for the networks involved in critical tasks, they are potentially prone to be attacked and modified by malicious users. So identifying such modification avoid the faulty functioning and can save life. So watermarking, it's here to ensure traceability and integrity for neural networks. Watermarking, it's a known research field in multimedia realm. It has behind some 25 years of success story and of in-depth theoretical and methodological studies. And this family of methodological and applicative tools are meant to allow for some metadata, for some additional data to be imperceptibly and persistently associated with some original content. And even when this original content is modified by some mundane or malicious operation, the metadata should still be retrieved. So while the background is well found and well known, extending watermarking from multimedia content to neural network, it's not straightforward, and it's a research challenge and a technological challenge as well. First, because watermarking insertion is no longer static as it was for media and becomes dynamic. Just consider the case in which the mark is inserting during the training, or the case in which that watermark is not detected from the model where it was inserted, but from the inference produced by that model. On the other hand, evaluating the watermark impact on inference, it's far more complex than on multimedia quality, as it depends both on the testing data set and on the applicative task. So to deal to these issues, MPAI identifies three families of use case. The first one relates to identify a neural network. So the metadata inserts provide a kind of ISSN of a serial number of DOI for the neural network itself. And not only for the neural network as it is frozen at a given moment, but for all its slight version, as for instance obtained by additionally training the network for one epoch. The second use case relates to identify the actors involved in a life chain of a neural network. It can consider identification for the creator, for the owner, for the legal user, for a legal distributor, and conceptually up to the next legal user of the content, to the one who let the unauthorized copy to be done. The third type of use case relates to verifying the integrity of a neural network and conveys information about where a neural network had been modified by a malicious user. To address these three use cases, a standard MPAI neural network watermarking had been released recently, and the scope of this standard is to evaluate three key aspects of a neural network watermarking technology. First of all, the impact of the performance of a watermark neural network on its inference. Secondly, how well a neural network watermarking detector or decoder can detect or decode a payload when the watermark neural network has been modified. And finally, the computational cost of injecting, detecting, and decoding a payload in the watermark neural network. So we shall come now with some details related to each of these three aspects. First of all, imperceptibility evaluation. The standard provides a methodology encompassing 4 incremental steps. First of all, define a pair of training and testing data sets which is with a size at least 10 times larger than the number of trainable parameters. Of course, this is a rule of thumb in neural network training, even outside watermarking. Then apply the watermark to a set of unwatermarked neural networks trained on the task, feeding the unwatermarked and watermarked neural network on the data sets, on the test data sets, and then to measure the task-dependent quality of the produced inference. Of course, the standard do not provide any particular measure for this quality, as it's too much task-dependent. There are differences in how to evaluate the quality of a neural network that it's involved in image segmentation or in speech synthesis. Second item, the robustness evaluation, also considers a 4-step evaluation approach. And the first 2 are identical with the previous one. So defining the testing and the data and the training data sets, and apply the watermark to a set of unwatermarked neural networks trained on the task. Now, additional and specific for the robustness, it's a step related to the modification, to the attacks that are applied to the neural network. Not that in our jargon, attack is not necessarily malicious, can be mundane operation like pruning, like quantization, like fine-tuning, like knowledge distillation. or a really malicious attack like watermark overwriting or some sophisticated protocol attacks. So the standard identifies and presents a list of common type of attacks. The MN watermarking technologies are expected to withstand, as well as a list of common parameters for such modifications. Finally, the robustness on the detector and decoder are evaluated according to the specific type of the method. So if it's can be bit error rate, can be symbol error rate, can be some, if the watermark is binary, can be some probability of false alarm and of misdetection, or can be F1 score and other of this type. Finally, the computational cost evaluation consider different approaches for the injection and detection decoding process. In the case of the injection process, the memory footprint is first evaluated, memory footprint for requirements for both CPU and GPU, and then some metrics related to the time duration of the processes. So the time to execute the operation required by one epoch normalized according to the number of batches processed in one epoch. In cases injection is done concurrently with the network training, the number of epochs required to insert the watermark, and the time for the watermark neural network to compute an inference. In the case of decoding and detecting, there are evaluated the memory footprint and the total duration of this process. In order to allow a easier usage of this standard, we also completed it with a reference software that it's also published as a standard. It's a very new one, has less than 1 month. So MPAI neural network watermarking reference software that has as purpose to provide an instance of MPAI neural network watermarking for the image classification task. Of course, the current implementation can serve as a guideline for other neural network tasks like segmentation or generic image processing application. The software it's developed in Python and has two key components: the injector and the decoder, detector or decoder. So these two components are wrapped, are merged, are integrated into more complex modules related to property evaluation, and we shall detail them again for the three types of operation. First of all, imperceptibility evaluation. The embedder module includes the injector as well as some pre-training and pre-processing in general modules. So based on the training and testing data sets as well as on this embedder module, the imperceptibility evaluation can be achieved. Second type of evaluation relates to the robustness. Here we also have the robustness evaluation and the detector decoder modules, but additionally we have the modification, the attack modules. So we need again the test data sets, the parameters, and the modification type and parameter. When relating now to the computational cost evaluation, we are mainly concerned with memory footprint and time modules that are generic modules, and they can be parameterized for the actual application. So the memory footprint to indicate which type of memory do we evaluate, and the time module, which process is to be executed. While this standard was managed in a very timely manner, so in only 1 year, we achieved this results, and we are very happy with them. Future work is still to come, and of course, one of the main aspects here is to further facilitate the usage of the reference software by developing some versatile and user-friendly APIs. We want here first to create the add-ons, the wrapper over the injector and decoder and detectors that allows for seamless evaluation of the watermarking technologies. Just to stress the points that actually these injector, detector, decoders are specified outside MPAI. So they are proprietary, and accessing their facilities in a sanitized and uniform way, it's a challenge in itself, and we count to solve it by defining some standard APIs and data formats for them. Second item here is the versatile configuration tools for MPAI NNW evaluation. And here the ultimate goal will be to make our software friendly for general inform AI user. So for somebody who has no special skills in the watermarking, but have a deep knowledge on how neural networks is expected to work. As a second item will be to further study and precise how MPAI NNW can be articulated with the MPAI AI framework, like a kind of particular service-like module for AIM modules that were presented and discussed earlier during this session, and also earlier today, at least today in the Europe side. And finally, we would like to promote the MPAI NNW standard as an IEEE standards. Efforts are already started. So the reference for the standard will be IEEE P3304, and we shall follow this process hopefully in the coming 6 to 9 months. These results will be done. So I think, I hope I kept the timeline. So please find more about MPAI in general and about this project in particular by following the links in this slide. Thank you very much.